Hello class, and welcome to section 8.3, which is about quadratic functions in standard form. By the end of today's lesson, you will be able to identify and graph the characteristics of quadratic functions in standard form. Standard form is f of x equals ax squared plus bx plus c, where a cannot equal 0. That was that initial format that I showed you in section 8.1. It is the more common of the ways you will see quadratic functions written. There are a few important characteristics that we can pick out from this equation. First, the y-intercept is at 0, c. So whatever this last numerical value is going to be our y-intercept. So if this is 7, we would have 0, 7. If this was negative 8, we would have 0, negative 8. The next thing we can do is we can still find our axis of symmetry and our vertex from this format. It just shifts how we do it. So to find our axis of symmetry, we're going to say x is equal to negative b over 2a. The a and the b come from the two numbers in front of x squared and x. For this negative b, it means whatever b is. So for example, if b is 4, you use the opposite. So you would plug in negative 4. If b started as negative 9, then you would plug in the opposite, which is positive 9. And then the a is whatever is in front of x squared. When you are putting it into the calculator, make sure you put parentheses around 2 times that number to keep it together. Once you get the answer from the axis of symmetry, so let's say, for example, x is equal to 3, you're going to plug that value into the x spots and solve for f of x. So solve to get that y coordinate of the vertex. So we're going to work on finding those three characteristics, starting with the equation negative 0.75x squared plus 3x minus 4. So we're trying to find the y-intercept, the axis of symmetry, and the vertex. One thing you may want to do until you get in the habit of just being able to recognize them is you may want to actually mark what your A, your B, and your C values are so that you remember what they are. Now our y-intercept is 0, c, so in this case it's going to be 0, negative 4. Then we're looking for our axis of symmetry that we're going to have to solve for. So I'm going to take that equation and I'm going to say x is equal to the opposite of b, so in this case the opposite of 3, which is going to be negative 3, over 2 times my a value, which in this case is negative 0.75. You would go ahead and plug that into the calculator and you're going to get an answer of 2. So that's going to be our axis of symmetry at x is equal to 2. That is also the x coordinate of our vertex. Now to find the y-coordinate, we're going to plug 2 into the equation. So negative 0.75 times 2 squared plus 3 times 2 minus 4. Now for the sake of the lesson here, I wrote it out so you can actually see what I am doing. When you are actually using this part, you can go ahead and just plug that into the calculator. You do not need to write that out on paper. And you're going to get an answer there of negative 1. So your vertex becomes 2, negative 1. Go ahead and find the three characteristics for this function on your own. Again, 0, c for that y-intercept, using the formula to solve for x, getting our axis of symmetry at x is equal to negative 1, and then plugging in negative 1 into the equation to get our vertex at negative 1, 7. Now, once we know how to find those characteristics, that also means we know how to graph. So when we are graphing, we're going to start again, just like we did last time, by identifying that axis of symmetry and the vertex. So I'm going to go ahead and solve then for my vertex point, my axis of symmetry, which is going to be x is equal to, in this case, we've got A, B, and C. So my axis of symmetry is going to be at opposite of 8, so negative 8 over 2 times negative 4, which is going to give me 1. So I'm going to go ahead and draw in that dashed line at my axis of symmetry. Then I'm going to go ahead next and get the rest of my vertex point. So plugging in negative 4 times 1 squared plus 8 times 1 plus 3. Again, you can just plug that into the calculator. You do not need to write that out. And that's going to give you an answer of 7. So my vertex is at 1, 7. So I'm going to go and plot that point. Then I'm going to go ahead and pick out my y-intercept, which is going to be at 0, 3. So I'm going to graph that point. And then just like last time, we're going to use that axis of symmetry to mirror. So I'm going to mirror that point over my axis of symmetry and then go ahead and connect those points with my curved line, making sure that it doesn't come to an exact point and that it is actually curved. Go ahead and try graphing this one on your own. Once you graph it, you find your axis of symmetry at 3, your vertex at 3, negative 5.5, and then that y-intercept at 0, 1, which mirrors across to 6, negative 1. The next thing we're going to do is do some function comparison with these characteristics, particularly the vertex. So remember that the vertex is that bottom or top point on the graph. So one of the things that's important to be able to do is compare different graphs in that sense. So we're having g of x be an equation, and our values for f of x are in the table. So we're not actually given an equation we can solve for. We actually need to pick it out based on this information. We're trying to compare the maximum value, which means I'm looking at this table, and for the f of x, I can quickly pick out that my highest point is at 10. So I'm going to say my maximum value is at negative 4, 10. If it asks just for the value, you would say 10. If it asks for the point of maximum or the vertex, you would say negative 4, 10. Then for g of x, I'm going to have to actually solve for that value because they give us an equation. So I'm going to use my x formula first, and I'm going to say negative b, so negative 2 over 2 times a, which is negative 1. Negative 2 over negative 2 is going to give me an answer of 1. And then I would plug that into the equation. One thing of note, if you have just a negative, and when you want to remember that in the calculator, plug that in as a negative 1, and then in parentheses, your 1 squared plus 2 times 1 plus 8. And when I solve that, that gives me an answer of 9. So my maximum value here is going to be at 1, 9. Our comparison then is between 9 and 10, with 10 being the bigger one. So I would say f of x has a greater maximum value. And that would be how I could compare using a table. You also can compare when it is a graph and a function. So when I do this, I'm going to go ahead, same process. Now I'm looking for a minimum, so I can go straight to my graph for f of x and pick out that low point. And I'm going to say f of x has a minimum at 3, 0. You're going to use the same process to find your g of x. So first you've got to find the x by doing negative b. So the opposite of negative 6 is going to be positive 0.6. And then times 2 times that a value, which is 0.3. 0.6 over 0.6 is 1. Plugging that into your equation, again, you can just plug that into your calculator. I'm going to write it out so you can visually see what you would be plugging in. And when you do that, you get an answer, in this case, of negative 1.5. So my vertex, my minimum point for g of x, then becomes 1, negative 1.5. This time we're looking for the minimum value. So I'm going to look between 0 and negative 1.5, which one is lower. So I would say g of x has a lesser minimum value. So it has that lower point on its graph. Go ahead and try this one on your own, looking to see which one has the lesser minimum value. For f of x, you can pick out from the table, it's at 1, 5. G of x you have to solve, and you get negative 2.5, 2.75, and that 2.75 gives us the lower minimum for g of x. The last thing we're going to do is convert between vertex and standard form, so what we learned about in 8.2, converting it to what we learned about today. One important thing is when you are converting this, you have to remember that what we learned in Chapter 7 about multiplying polynomials, you can go through and use the box and say x and 6 and x and 6 and multiply to get all of those values on the inside. I highly recommend You go back, you look at the shortcut, and you remember it because it will save you a lot of time. So I've got f of x is equal to negative 0.3 times that shortcut. Again, square the front number, so x squared. Multiply the two things inside the parentheses. So I've got x times positive 6, which is going to be 6x. Double that, that's going to give me a positive 12x. And then square the back, which is going to give me 36. Parentheses, that minus 9 stays on the outside. The next thing you're going to do is distribute that negative 0.3 or whatever your a value is. So in this case, I've got f of x is equal to negative 0.3 x squared minus 3.6x minus 10.8. And then we still have that minus 9 on the end. The last part is always going to be to combine those two numerical values at the back, the ones without the x's. So I'm going to end up with negative 0.3 x squared minus 3.6x minus 19.8. And that is my standard form of the equation. Go ahead and try this one on your own. Again, use that shortcut to get what's in parentheses. Distribute the 5 to everything but the 1 because it's on the outside. Add the 1, gives you a final equation of 5x squared minus 60x plus 181. If you have questions about this or anything else from the lesson, please let me know when you get to class.